Okay, first, if you haven't done these things, I want you to do these first. One, read chapter one. Two, look up the scientific method and find out a little bit about that and who the people were that were involved in creating it. And third, look up Galileo, and I want you to take a look at some of the problems that he had with the church, especially, and see some of those things. And then I want you to think about this question. Which of the following statements below is a scientific claim? Human beings will never set foot on the moon. Some of the laws that govern nature cannot be detected by scientists. It is quite possible that in some other galaxy the laws of physics are fundamentally different than the laws we are acquainted with in this galaxy. Which of those is a scientific claim? Welcome to Chapter 1 of Physics, and this is the first of the videos for the flipped classroom, and hopefully you guys enjoy this style. I think it gives us some real possibilities of doing some extra stuff in class that we couldn't normally do, so hopefully you get a lot out of it. The idea here is that you take notes. You should have your physics notebook. Put your notes in there. Occasionally there'll be things that I'll ask you to look up and to do, and you should do that and put those things in there. There'll be some questions here at the end I want you to answer, and then those kind of things we'll talk about tomorrow when you come to class. So let's take a look at physics. If we're talking about physics, first of all, it talks about the earth here, and we can't control the motion of the earth, but we can study it. We can learn a lot about those things, and we're going to do that in the course called physics. And physics is probably one of the more basic sciences. It's not as complicated as some of the other things. It doesn't study living things, which are very complicated. It's kind of the general one before you get into everything else. And so this would often be considered the basic science that we have, most basic of all. Chemistry, we would get into a little bit about putting matter together. Biology, probably the most complex of all of those because, like I said, it involves matter that's alive. And in some places, biology is the class that you don't take until you're a senior because it is so complex. If you get into all of the chemistry and all of the things in biology, it can be a very complex class. In physics, we use mathematics to express our things. And the nice thing about mathematics is it tends to be unambiguous. We know what the number is. We understand that. And so we're going to do a lot of equations in here. And I'm not super big on memorizing a lot of those. There's going to be some basic ones that I'll expect. But mostly I want you to be able to work the equations. That's more the important thing as we go through this. One of the important things, and this is something that you cover in every single class, is the scientific method. And it's always considered, or it's always something that you cover in the very first section. And when we're talking about the scientific method, we're talking about a process to solve a problem, basically. That's what we're doing. So number one, you need to recognize what the problem is. I like my flashlight example. If I have a flashlight and it doesn't work, that's my problem. So number one, I figure out I've got a problem. Number two, you make an educated guess or a hypothesis about it. So if I have my flashlight, I say, I think it's the batteries that are broken or bad, and then the third step is I go and predict what I think will happen. Well, I think if I put in new batteries, it'll work. And I go and test that. I have an experiment, and I test what I'm going to do. And guess what? If they work, if I put in new batteries and it works, then I know that I was correct. And if I put in new batteries and it doesn't work, then I have to go back and reevaluate what I just did. And maybe it's the bulb instead of the batteries or something else. Okay, so you have some basic rules that you go through with the scientific method. When we're studying the scientific method, there are usually two main people, at least your book talks about two main people, that are credited with this, Galileo and Francis Bacon. Those are two people who, when was it? I'm not exactly sure, 1600s, they started kind of talking about how can we do things a little bit better. And these two guys are very influential. What I do want you to do now is stop the video, and I want you to spend a minute, and I want you to look up a couple things. I want you to look up a little bit more about this. These are 2 people, but there are several others that are involved. And I want you to write those, find some information on some other people, and write about them. The other thing that I want you to look up is some of the problems that Galileo had with the church, being a scientist and things with the church. And those are things that I want to be able to discuss in class tomorrow. So go ahead and stop the tape and go ahead and look that up for right now. Okay, even though scientific method is great, it is not always the main way we figure things out. A lot of times, believe it or not, it is trial and error, or it is a mistake. Something accidentally happened, and that's how we figured it out. It is amazing how many of those things happen. And, you know, if you think about penicillin, for instance, and how, you know, the mold got into his bacteria he was growing. And because of that, because of an experiment that had gone wrong, we come out with penicillin, one of the best, greatest medicines and things that we've ever come up with. So, you know, there's a lot of trial and error in this. And it has more to do, the success of it has more to do with, you know, inquiry. Are you just trying to figure stuff out? You know, experimentation. Are you willing to look at stuff and see what's there? And that's kind of the key for all of those things. All right, let's talk about facts. First of all, if we're talking about a fact, we're just simply talking about something that is a close agreement by a lot of observers. People agree that, hey, yeah, this is what it is. Okay, you know, it's 3 inches long or whatever. Those are facts. Whereas a scientific hypothesis, and they've added the word scientific, that does become important here in a little bit, is an educated guess that, you know, it's not fully accepted. We're going to have to test it out. We're going to check it out and see if it does work over time. Then we might come up with something we call a law. You know, we have the law of gravity or a principle, and those are different things that we would get as time goes on. The other thing that's important is it is important to be willing to change as you go through some of these things, because sometimes you find things that are different. When we're talking about a scientific theory, a theory is usually considered to be, you take a lot of information, put it together, and it kind of explains things about the world and how it happened. And there are theories, and the thing about a theory is you cannot directly prove a theory. You can disprove theories, but you cannot prove them. But they explain how things work, and that's the important thing, is that they explain the facts that we know at the time. And obviously there are some disagreements on theories, and we'll probably even talk about that in this class. But they are things that you need to be aware of and you need to understand. Okay? As you go through and you work on your theories and you refine them, they get better and better and better. If you guys have been in chemistry, you understand the idea of the atomic theory and how much that changed, and how originally they thought atoms were, you know, just an indivisible thing, and then we found out, oh, there's protons, neutrons, electrons. Now we know there's even smaller particles than that, and so that has just continually been refined as we've gone through all of these things. Now, let's talk specifically about a scientific hypothesis, and here's the key thing. The scientific hypothesis must be testable. It must be able to be proven wrong. That's the big thing, and that's kind of a little bit hard to think about, but you got to be able to prove it wrong when you do it. If there's not a test for wrongness, if you can't prove it wrong, it is not scientific. It might be a hypothesis on something else, but it is not a scientific hypothesis. That's the important thing when we're talking about that. All right, so let's take a look at these couple examples. It says no material object can travel faster than light. Well, this is a scientific hypothesis. So far, we've never found anything that has gone faster than light that has been physical, you know, has mass. But if we were to find one, we could disprove it right away. One fact could disprove that, And that's what they're talking about. That's how it needs to be scientific. Let's take a look at these. First one, the alignment of planets in the sky determines the best time for making decisions. Well, how would you determine whether that's true? Or how would you determine whether that's wrong? How could you prove that? Either one. You can't. It's just speculation. So this is not a good scientific hypothesis. Or how about intelligent life exists on other planets somewhere in the universe? Now we could prove that right. We could prove that, yeah, there is, but we could not prove it wrong. And if you can't prove it wrong, it's not a scientific hypothesis. Or the third one here, most people stop for red lights. Well, you know what? That doesn't really have much to do with our understanding of nature, so that wouldn't be considered scientific when we're talking about that kind of a hypothesis here. Of course, in order to test our hypothesis, we're going to do experiments. We like to do those. I want you to think about this, okay? Take a look at this. Which of these is a scientific hypothesis? Write it down. We'll talk about it tomorrow. All right, section 6, science, technology, and society. And I just want you to be aware of some of the things of how these things interact and how we have things. When we're talking about science, science is just basically discovering facts. And when we're talking about technology, we're talking about taking these and putting the ideas that we find in science and putting them to use, finding uses for them. So the science might have been, hey, we can create radio waves that we can send across around the world. The technology would be the radio that goes along with it. Okay, technology is kind of the good part of what we're doing. Makes up, probably the important part of our life. Science, art, religion. These are all interesting. This book kind of talks about how these things would be arranged in different things. And in the domain of science, we would think of things as natural order. In the domain of religion, we would think of it as talking about nature's purpose. Why are we here? What's it all about? That's religion. Science is more figuring out how it works, okay? And, if we're talking about art, we're talking about, our things that make our life enjoyable, okay? Literature, we talk about literature, we talk about music and those types of things. That's art, and those things make it more enjoyable for our lives. All right, I'd like you to answer this question in your notes. Which of the following involves great amounts of human passion, talent, and intelligence? And we'll talk about it tomorrow. All right, taking a look at the last things here. In perspective, if you think about how things have changed over the past several thousand years, if you look at like the pyramids, man, that took a lot to build those pyramids. Now we could do those in probably a few weeks. Those probably took them years, maybe even tens of years to build them originally. So things have changed quite a bit. Today we can do, we can go to the moon, we can fly people from one part of the world to the other. So there's so many more things that we're able to do now. But, what do you suppose will be when you guys are in your 50s and 60s and stuff? Who knows? Maybe someday we will travel in a spaceship to other planets or things like that. All right, a few questions for you to answer here. Take a look at these. Okay, which science is the basic science? What is the language of science? Classic scientific method followed by Galileo and Bacon is? Which of those? When someone says that's only a theory, that person likely doesn't know that a scientific theory is a... For a hypothesis to be scientific, it must be... Technology is a... Science differs from art and religion because it... Which of the following statements about progress today compared with progress centuries ago is true? Make sure you get all those in your notes, and we will talk about those in class tomorrow.